Next, let's talk about images. So we can't really have very large images on our websites because people are constrained by their different speed internet connections. So what we're going to do is we're going to compress our images to make them as small a file size as possible without compromising the integrity of the image. These are some common file types that you'll see on the web, such as GIF, JPEG, PNG, bitmap, and SVG. To understand the differences of these different data types, we'll have to learn a little bit about lossy versus lossless. So lossless data compression makes use of algorithms that allow the exact original data to be reconstructed from that compressed data. And that's in contrast to lossy data where the compression does not allow the original data to be reconstructed. So lossy involves losing some information in order to make the file size smaller, and lossless is an algorithm that allows you to reconstruct the original data from that compressed item. So GIF, or graphic interchange format, is an example of a lossless compression type, and the way that it makes the file size smaller is by simplifying the color palette. So this is a good choice for sharp-edged graphics with a smaller range of colors. So a logo like the Nike logo, or something with a very simple color palette and sharp edges, it's perfect for that. However, it's not good for things with complex colors such as gradients. So if you're looking at something like a painting or a photograph of a person's face, then a GIF isn't going to be the best option for compression. So instead, if you have something like a photograph, you're better off using a lossy compression type, which you'll lose some of the image fidelity or the resolution of the image, however, but it's going to be a little bit better for smooth variations of tone and color. Now we also have the PNG8, which is Portable Network Graphic, and this is the 8-bit version of it. This is also a lossless data type that was meant to replace GIF, and so you'll see these both floating around. I tend to use PNG over GIF because it's a newer file format, and it does a great job with some of the same things as GIF, such as sharp edges and simplified color palettes. Again, if I have something with millions of colors or smooth changes of colors like gradation, then I'm going to still want to go with a JPEG over a PNG. We also have the PNG24, which is the higher 24-bit resolution version of the PNG. And this one has excellent results for transparency images. So this one's great for like user interface buttons, and it's good at sharp edges and simplified color palettes, as well as a large color range of gradients. Still, if you have an image such as a painting or a photograph, JPEG's still going to be the smaller file size, however. And we also have SVG, which is the Scalable Vector Graphic. Now this is an interesting lossless format, and this can be optionally defined as vector points instead of pixels, which will allow the graphic to scale up and down. And so this is excellent for logos and things, or for maps or details like icons that need to scale up and down in size on different devices. Now, one thing worth mentioning is that this doesn't have quite the range of support that the other file types have. So you might run into troubles in older versions of Internet Explorer. So let's talk about choosing resolution for the images. So a typical screen only has 72 pixels per inch. So most web graphics are compressed down to 72 dpi, or dots per inch, or you may also interchangeably hear the term ppi, or pixels per inch. And that's in comparison to, for example, something like a newspaper is 100 dpi, a nice printed piece would be around 300 dpi, and the only exception to the 72 dpi screen is of course on special retina display devices like the Apple iPhone and iPad, which currently at the time of recording this have screen resolutions up to 326 dots per inch. So when choosing color modes for web, we're going to use RGB, which stands for red, green, blue, as opposed to CMYK. CMYK is meant for print, and it breaks the colors down into the different color plates that you'll see on an offset printing press, which are cyan, magenta, yellow, and black. Now, RGB is the actual colors that the pixels on our screen have. So our screen actually combines a combination of red, green, and blue in various amounts to create millions of different colors that we see on our screens.